Okay, so basically what you're doing here is you are proving them algebraically, so you have to plot them first. So P is -3, 1. Q is 1, 3. R is 5, 1. And S is 1, -1. So that, oops, is what our quadrilateral should look like. You should have more straight lines and they should connect better than mine. But then now we have to compare them. So we need the slope and the distance of each one to help us prove what kind of quadrilateral it is. So with PQ, we're going to do the distance formula. X2 minus X1 will actually be a plus because it's negative. Y2 minus Y1 squared. So 4 squared plus 2 squared, 16 plus 4. So it is equal to the square root of 20. And then do the distance formula with these points. 1 minus 5 squared plus -1 minus 1 squared. Then -4 squared plus -2 squared. 16 plus 4. So they are congruent because they both have the same distance, so the same length. Now we need to find the slope. So the slope of PQ is up 1, 2 over 1, 2, 3, 4. So it's 2 over 4, which simplifies to 1/2. And then RS is up 1, 2, 1, 2, 3, 4. It is the same. So they have the same slope. So PQ is parallel to RS. And then we have to compare these sides now. So plug these into the distance formula. 5 minus 1 squared. 1 minus 3 squared. 4 squared plus -2 squared. 16 plus 4, square root of 20. Last one, 1 plus 3 squared plus -1 minus 1 squared. 4 squared plus -2 squared. 16 plus 4, square root of 20. Find the slope of PS, up 1, 2, up 1, 2, 3, 4. So that's -2 over 4, which simplifies to -1/2. And then QR, up 1, 2, 1, 2. So it's the same thing. So they have the same slope. And so it's parallel to PS. So now we know the slope of PQ is 1/2, and that's this side, and the slope of QR is -1/2. Are the slopes opposite reciprocal? No. If yes, they would be perpendicular, but they are not. So they are not perpendicular. So we're still trying to figure out what type of quadrilateral this is. We know that PQ, it was square root of 20. And we know that QR was the square root of 20. So they have the same length. So they are congruent. So we can say that this quadrilateral is a rhombus. Explain why all 4 sides are congruent. We know it's not a square because the 2 sides weren't perpendicular. So our angles are not 90. Oh, you guys didn't see that bottom part. So they do have the same length. All sides are congruent, so that means it's a rhombus. So those are all the steps we would go through for one shape. And we've got 3 more shapes to do. I'm going to go into the next one. So we'll plot these. P is negative 4, 1. Q is negative 1, 5. R is 3, 2. And S is 0, 2, negative 2. So there's my quadrilateral. Da-da-da. Now I have to go through and I'm going to find the slope of PQ. 1, 2, 3, 4. 1, 2, 3. 4 over 3. Slope of RS. 1, 2, 3, 4. 1, 2, 3. They are the same, so they are parallel. Find the slope of QR. 1, 2, 3. 1, 2, 3, 4. Negative 3 over 4. PS, 1, 2, 3, 1, 2, 3, 4. Negative 3 over 4. They have the same slope, so they are parallel. And it is 4 over 3, negative 3 over 4. Are these opposite reciprocal? Yes, they are. So they are perpendicular, which means that those angles are 90 degrees. Then we've got to find the distance to see if all the sides are congruent. So plug it in. Negative 1 plus 4 squared plus 5 minus 1 squared. D equals 3 squared plus 4 squared. 9 plus 16. Square root of 25. D equals 5. Same thing here. X2 minus x1 squared plus y2 minus y1 squared. 4 squared plus negative 3 squared. 16 plus 9. So they are the same. So I can say yes, they are the same. They are congruent. It's a square. All 4 sides are congruent. And all angles are 90 degrees. And you guys can't see that bottom part again. So really you're just finding the distance and the slope of each one, and then once you find that, you can figure out what shape it is. So 2 more here. P is 0, 6. Q is 2, 3. Negative 4, negative 1. I'm writing on a little ledge. And then S is negative 6, negative 2. I plotted something wrong. Negative 6, positive 2. That's where my S should be. Okay. So we have to find slope of PQ. Slope of PQ up 1, 2, 3 over 1, 2. It's negative 3 over 2. RS 1, 2, 3, 1, 2. Negative 3 over 2. They have the same slope. They are parallel. QR is up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So it is 4 over 6, which simplifies to 2 over 3. PS 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So those are also parallel. The slope is negative 3 over 2 and 2/3. They are opposite reciprocal. They are perpendicular. Now we gotta find the distance. We probably know what shape it is at this point, but we've still gotta double check. So x2 minus x1 squared plus y2 minus y1 squared. 2 squared plus negative 3 squared. 4 plus 9 equals square root of 13. Negative 4 minus 2 squared plus negative 1 minus 3 squared. Negative 6 squared plus negative 4 squared. 36 plus 16, square root of 52. They do not, they have different, not just not. They have different lengths. Are they congruent? No, it's a rectangle. Explain why. 4 90-degree angles, but only opposite sides are congruent. And you can't read that again. Every time. Okay, that is that one. We have got one more. Zero, -1 is P. 4, -1. I did that in the wrong place. Q. R is 3, 6. S is 1, 6. I hope that is right. Let me connect. Oh, I didn't label this one S. Okay. Slope of PQ is 0. Slope of SR is 0. They do have the same slope, so they are parallel. Slope of QR is 1, 2, 3, 4, 5, 7, -7. That's going to be a +7. Different slope. And so we would just say not parallel. Slope of PQ is 0. Slope of QR is -7. They are not perpendicular. And then I haven't showed you any of this because I didn't scroll down. Distance formula. x2 minus x1 squared, y2 minus y1 squared. 1 squared is 1, 7 squared is 49, square root of 50. And then same thing here. x2 minus x1 plus y2 minus y1. 1 squared is 1, 7 squared is 49. They are the same. So, yes, yes, it is an isosceles trapezoid. There's an R there. Explain why. One pair of parallel sides, and they have congruent legs. Okay, that is it.